Hello everyone, thank you for joining this session. So I'm Timothée Moulinier, working from GICAN. We are the French Industry Association, representing a bit more than 300 companies working in all the supply chain to build the ships. And I'm very happy to be here with three of our members of this industry. So maybe you can give a word about your company and what are you doing for her.
Hello everyone, I'm Sébastien Rousset, Chief AI Officer at NAVAL Group. I'm in charge of the strategy and governance of AI within the group. Just a quick refresh, NAVAL Group is an international player in naval defense. We are the partner of governments in assigning sovereignty over the sea and the oceans. NAVAL Group masters the whole life cycle of the warships. We design, we build, we maintain, we repair, and we upgrade our warship. So it's quite single skills that not a lot of companies could have within the world.
Thank you. Maybe Alice, you can introduce Delfox.
Thank you very much. Good evening, everyone. So I am Alice Memang. I am the co-founder of Delfox, and I am also the executive manager. Delfox is an AI-first startup, which is specialized in deep reinforcement learning. We deeply believe that deep reinforcement learning is the efficient technology to overcome the issue of autonomous system. And we have been pioneering deep reinforcement learning since 6 years ago by helping our customer shift, because there is shifting needed, from automatic and static system to progressive autonomous systems.
Thank you. And Mikael, maybe.
Hello, everyone. So Mikael, founder of two companies. The first one is OZ Engineering. It's a services company where we develop AI solution for our customer in different fields of the industry. We work on automotive, railway, and recently a lot on maritime systems. And I found another company recently, it's AEGIR, where we focus on the collaboration between different systems to realize a complex mission in a maritime situation.
Thank you. And so as a name for this table, we wanted to talk about the operational superiority. And so us in the maritime sector, it's like it starts with like the manufacturing part towards to the full operation. And so this is a bit what we wanted to show with our example. But so maybe with you first, Alice, at Delfox, how this operational superiority, your product and the AI within your product can give your customer and your partners this operational superiority?
Okay. First of all, when we talk about superiority, operational superiority, it's important to know what it means. According to our posture, superational operationality is the ability to give the force and advantage to overcome the enemy, to overcome the difficulty they are going to meet on the field. And that's why we have been developing autonomous system. We have developed a platform, a deep reinforcement learning platform, which is RealMind. And we have designed it to help our customer to develop their autonomous system first in a simulation environment. The way is to reproduce a realistic environment in which the agent, the AI, can learn, to develop strategy, to develop scenarios that they can meet on the field. And when we have intelligent behavior and optimistic behavior, then we can bring this behavior and the main system and to put it on the field. It's very important that we conserve the same efficiency in the simulation than in the reality, because the system, the AI system, are going to be interact with the reality. This is how we are working in the first place.
So a lot of simulation, and then after it goes to the real world, how it interfaces then with the reality and the world of the different vector you're embedded within.
Yeah, so we are working with vectors such as drones, satellites, and also SM on all the area, ground system-based, drone aerial system-based, or naval maritime system-based. What is important is that we are working hand-to-hand with our client because they have the expertise, and they are going to give the expertise in the environment simulation, and the AI is going to learn about what is the mission, what the point of the mission is. So it's going to take, of course, all the characteristics of the mission, all the constraints in the environment, because they are dynamic and moving and changing environment, and there is going to propose the best scenario, mostly where the predefined scenario is really obsolete. So it's going to give a scenario, and it's important to know that the operator will always approve the scenario before letting the AI interfere in the reality. And then we have what we call the reality gap, which is the shift between the simulation and the field. And we have to help our client maintain this gap.
Yes, thank you. And among all those scenarios, one of them is with NAVAL Group, and with the various things you build, like submarines, warship, surface ships, and so on. So a bit how there's operational superiority as a manufacturer of those objects going at sea. How is it perceived in your company?
Well, operational superiority is achieved with warships that are sailing the sea. That means that we have to maximize the availability of our warship at sea. And it starts to innovate within the design process. And I will give you some examples for all the life cycle of the products, just to figure out how AI really helps. First, during the design phase, AI is used to optimize all the design and all the details. For example, at the start, we design what we say the general arrangement, and simply optimization algorithm could optimize the pipe and cables routing within all surface ship. And that's not cost-saving issues. It's also upgradability, repairability, and upgradability of our systems that is a concern. And having systems that could be evolved easily is something important to keep the availability at sea. We also use AI to capitalize from previous program we already performed. The main example is that we use AI to analyze past analysis, analyze the root potential causes, and to suggest solutions we integrate in the design of the future warship. And when our warships are designed, then they are sailing the sea. And we have to maximize the availability at sea. And something quite easy is to understand what we need to implement preventive maintenance that can allow us to not to replace all the equipment and parts when at a predefined frequency, but to define the just-in-time necessary time replacement. That extends all the equipment lifespan, but it also reduces the unplanned downtime, and that's very important for our Navy. Let's figure out another point of view when our ships are under construction or under maintenance. Well, when they are stuck in the shipyard, we have to plan all the activities to conduct during the maintenance operation. And the shipyard is quite a complex environment involving hundreds of trades working simultaneously. AI can plan very meticulously all the tasks that can avoid the core activities, which is a very dangerous, that could be a very dangerous environment for our workers. And AI can also plan activities to avoid or to optimize the flow inside the warship that can also provide some significant safety improvement.
And maybe into the battlefield, how is it going when all your equipment with the different ships working together and so on? How is it conceived within Naval Group?
Obviously, the operational superiority is achieved when our warships are facing the battlefield. And well, operational superiority is mainly achieved by informational superiority. Nowadays, our frigate, the multi-mission frigate, records almost 3,500 information in real time. Tomorrow, our future frigates will probably record 45,000 of parameters in real time. And that's totally impossible for a human brain to compute all this in real-time data. And there's where AI will provide this capability of analyze and provide information and computable information to the sailors. Tomorrow, probably drones will integrate the battlefield, and the quantity of data that will be to be managed will absolutely be uncomputable by the crew. And AI will be the solution.
Yes, so a lot of decision making, and so this gives me the floor to you, Mikael, about this decision-making tools. How is it within your company that it's a lot what you provide to your customer? What is a bit the process you work with to achieve this good decision that is for the client?
Yes, thank you, Timothée. So we will make a focus on the maritime industry. When you think about operational superiority, you will first think about the defense industry, but you can think about the civilian industry. For us, for OSI, we develop solutions, for example, to reduce the CO2 emissions of different vessels. When you think about a cargo carrier, they have to go through the ocean. So there is some algorithm, like we call weather routing algorithm, that help them to reduce their CO2 emissions and reduce their fuel consumption. So first part for the superiority in the civilian world is today the reduction of the CO2. The second part will be the efficiency of the operation, meaning by a good planification, by good planning of all your operation at sea, you will be more efficient, so you will deliver more with less money. And last but not least is like safety. At sea, safety is important. We are working on very huge vessels that cost hundreds of millions of dollars. So safety first. And AI can help you develop safety solution. For example, with how you manage your environment, how you treat all the data from different sensors. We can think about radar, LiDAR, video, and how you take decision about this data from these sensors. So this is what we do at OSI. Our first product knowledge is to develop decision-making tools, meaning helping the operators to have a decision, to take his decision. So we power these tools with AI, and we go through all the way to autonomous operation, meaning the AI is embedded in the system, and the system will operate autonomously. So this is where we talk about one system by one system. Today, we are at the era of the robotic for maritime. There is a lot of robotic systems. We have unmanned surface vessel, which is you can see on the war in Ukraine, for example. You have aerial unmanned vessels. You can see also on the battlefield, and you have autonomous underwater vessels, which is like submarine, like go deep in the sea. And today, the challenges for maritime operation is to coordinate the system. It's very complex. You have the thousands and thousands of systems to coordinate, and the human is not really good at it. So you have to use algorithm, AEGIR algorithm, that will help you to make the coordination of the system, make your planning, and to have the best effect on the field.
Yeah, so here you have a bit an example of all the different civilian market, the defense market. This is the dualities that you find in the maritime. But maybe one question for all of you is a bit how today AI, do you consider it deployed? Do you consider it under deployment, under test? What is a bit the human factor acceptances for within the companies, but also within the people on board? What is a bit on this deployment? How is it perceived from your customer, Alice?
This is a very important and recurring question. To take an example, one of the use cases we have been working on, it's a collaborative combat. Collaborative combat is a form of combat. You have to manage resources from the ground, resources from aerial system, and resources from satellite. So it's important. The operator already knows that there are a lot of information and a lot of things going on the field, so they have to be efficient in taking decision. But this decision, if they have to take it with tools, they have to be they have to trust in these tools. So what our customer asks us is, okay, you are providing us with autonomous system, but how is it going to be usable for us in total trust and a total knowing of what are the decisions they are going to take and how they are going to apply this decision on the field. So we are developing with our solution explainable autonomous system that operator can question during training, so they can know exactly what have oriented the decision taken by the system all the way through, so they can also collaborate. And it's important to know that our systems are autonomous, but they are systems that are manageable for the operator. It's the operator which will take the final decision in an operation.
Yes, thank you. And there's a trust on AI system, there's explainability and so on. But in NAVAL Group, the big company, how is it perceived within the employees of NAVAL Group? I mean, all the business line and the product developer, how they use it? And after the navies, the clients, so far, have you been able to sell to them AI product, or what is a bit the deployment of it?
I'm totally in line with what Alice mentioned. The key factor is trustworthy AI, explainability, and AI that fits end user need. To deliver this kind of AI, I always affect a squad, a multidisciplinary squad composed with functional experts. The end user, a technical expert, an AI expert, engineer, but also a human factor specialist, an ergonomist, cognitive psychologist, that to really think the innovation very user-centric, even though social-centric design in case of collaborative systems.
Yeah, so actually to deploy this AI, you need actually a mix of team that is different from different background to handle this complexity of human. And a bit what is your perception on your market, on the civilian market? Is it faster than the defense market, or how is it? How do you feel it?
Yeah, so the maritime industry is quite conservative. So AI and all data analysis, everything will take more time than in other industry to be deployed. Today, in the civilian world, is going faster than on the defense industry. Why? Because there is a progressive adoption. First, they will go on a decision-making tool, meaning there will still be the operator, they will still do his job, but with a little assistance that will help you do his job. And after that, they will go on remote operation, meaning the operator will be on shore. And after that, it will go on full autonomous operation. And at OSI, what we do for the adoption of AI, we will adapt the technology that we will use in the AI algorithm, meaning we will go from a white box model, meaning they're really explainable but maybe less powerful than black box model. But when the user gets used to this type of model, which is quite powerful still, we will make them go to the path on more AI and black box model. So we make our end user progress on the path to from explanation to performance.
I think thank you very much for your insight about this maritime industry and how you feel it. And so us at GICAN, we try to federate a bit this change, this transformational change, and to see through the full life cycle of our ships, like going from the shipyards toward operations. So there is also here a competitive advantage of French industry to be gained with this new technology, and in this modern world with a lot of competition going from Asia and so on, it is really a lever we need to activate widely. Thank you very much for your insight.
Thank you.
Thank you.